In this video, we will give an overview of how IKAN ALM can be used to manage the lifecycle of your application. Using a basic example, we will show how IKAN ALM integrates with Eclipse, Subversion and JIRA, how you can control the execution of builds and deploys using the approval management functionality, how you can automate the build and deploy processes using IKAN ALM phases, and how you can trace what happened during the different steps in the lifecycle. In this demo, we will go through the different steps of creating a project and defining the lifecycle levels and environments. We will execute a build and deploy the result to the test environment. In the Global Administration section, you define how IKAN ALM can establish the connections to those external systems. In principle, this is done by the Global Administrator. Here we see the subversion definition. It specifies, among other parameters, the locations and the structure of the repository. The JIRA definition specifies the connection details and also contains the patterns used for the issues and issue IDs. The first thing to do after all connections and global administration aspects have been defined is to create an IKAN ALM project. For this demo, we will create a release-based project. This type of project works with the existing structure in the version control repository. When the build process will be started, the objects that need to be extracted will be automatically retrieved from the VCR. To start, you add a name and a description for the new project. And next, you specify the connection with the VCR and the name of the VCR project, as well as the connection with the issue tracking system. You specify the build and deploy tool types and the scripts that need to be used for the build and deploy processes. On this screen, you can also specify the settings for the head project stream that will be automatically created at the same time as the project. We will come to that a bit further in this video. For this demo, we will only specify the build prefix and leave the default values for the other settings. Before actually creating the project, you can check the existence of the project name in the VCR. When everything is fine, you click the Create button and the project is defined. As mentioned before, at the moment the project is created, IKAN ALM will automatically create a head project stream. A project stream is a working entity within IKAN ALM. Each IKAN ALM project contains exactly one head project stream and may contain one or more branches. Main development will mostly be done in the head project stream, while maintenance, patches and parallel development can be realized in those branch project streams. For this demo, we will only use the head project stream. A base lifecycle has also been created automatically for the project. In IKAN ALM, the lifecycle specifies the logical steps of the ALM process. Such a logical step is called a level. An IKAN ALM lifecycle can be made up of three types of levels: build, test or production levels. Each of those levels is connected to an environment which is hosted on a physical machine. The definition of the build level contains the name and description as well as the information about notifications and schedules. In this example, a continuous build schedule has been attached to the level. This means that every X number of minutes, the scheduler will check for changes in the version control repository. If changes are found, a build level request will automatically be created. A key functionality of IKAN ALM are the phases. By default, some core phases have been added to the level. IKAN ALM phases are predefined, parameter-driven, reusable package building blocks. They represent specific tasks or actions that are executed to automate the lifecycle management process. Phases added at the level will run on the IKAN ALM server. In this case, for example, we have the retrieve code phase, which will check out the source code from the VCR and copy it to the appropriate location. The build phase will activate the execution of the build, and at the end everything will be cleaned up. The deploy phase is redundant in this case and could be removed. The issue tracking phase has been added because we linked an issue tracking system to our project. We won't go into the details of the usage of phases at this point. The important thing to remember is that phases can be added or removed depending on your requirements and the tasks you want to execute. Now that we have our build level, we need to connect it to an environment. The definition of the build environment specifies the name as well as the source and target locations and the build script that must be used. Furthermore, you can decide to make the build result downloadable. And most importantly, you link the environment to the required level, in our case the build level. You also specify the machine, or in other words, the IKAN ALM agent where the build will be executed, and the build tool to be used. Just as for the level, a series of IKAN ALM core phases is attached to the build environment. You can display them by clicking the Edit Phases icon on the build environment's overview. As said before, phases are very flexible. In function of your requirements, you can add or remove phases. Since these phases are linked to a build environment, they will run on the IKAN ALM agent, which is a machine linked to your build environment. Basically, what will happen here is that the transport source phase will transport the source code that was retrieved from the VCR. The verify build script checks whether it can find the build script, and if so, the execute script phase will start the build script. The transport deploy script guarantees that deploy scripts necessary for deployed higher up in the lifecycle will be added to the build result. Since there is no deploy environment yet, it will be ignored. The build will be compressed and archived, and at the end everything will be cleaned up. All project components to launch a first build have now been defined, but the project itself is still locked. So first you need to audit the project to make sure its configuration is consistent. So far, we have created a project with a head project stream to which a lifecycle has been added. The head project stream is linked to the trunk of the project in the VCR. As a first step in the lifecycle, a build level has been defined, which is connected to a build environment which uses IKAN ALM phases to execute the build process. All components are set up for our build process, so now we can create a build level request. To easily follow up and manage your projects, you can add the project to your desktop, which is in fact a dashboard for the lifecycle actions. This will provide different view options and shortcuts for creating level requests. This first build level request has already been created automatically, as we attached a continuous build schedule to the project. To illustrate the IKAN ALM build and deploy processes, we will use a demo application called Customers Demo. What we will do in the next part of this video is make a change to the application in Eclipse and commit it to Subversion, start a build level request in IKAN ALM to retrieve the modified objects, and deploy the modifications to the test environment using two specific solution phases. Let's first show the initial situation. This is a customer's demo application. Its database contains a list of customers. Some of those customers are dummy ones used for test purposes. To show how the integration with Eclipse and the version control repository works, we make a small change to one of the objects and commit that change to Subversion. As description, we add the ID of the related issue in JIRA. Based on this description, IKAN ALM will automatically create a link to this issue ID. As we added a schedule to the build level, the build will be automatically created within 5 minutes, which is a delay of our schedule. You could also force the creation of the level request. In that case, the link Show Modifications will provide an overview of the changes that will be contained in this build. In this case, the modification to the name of the application properties file. When the level request is finished, you can check its details. The Phase Logs tab page lists all level phases that have been executed. If we select the build phase, we will find all phases executed on the build environment. Let's for example have a look at the execute script phase. You can also display the build parameters used by the build script. On the Results tab page, you will find the build result, which you can download and save if required. On the Sources tab page, you will find an overview of all the sources used. And the Modifications tab page displays all the changes. The build process is now finished. Next, we want to deploy the code to test. Therefore, we need to go back to our lifecycle and define a test level and a deploy environment. The procedure for creating a test level is similar to the one for the build level. You fill out the fields, specify the lifecycle, and click the Create button. Next, the level needs to be linked to an environment. Since we want to deploy our previously created build result, we must create a deploy environment. This is also similar to what has been done for creating a build environment. The extra link to the build environment ensures that we will deploy its build result. Just as for the build environment, the deploy environment comes with a set of default phases. The build result will be retrieved from the archive and decompressed. The verify deploy script checks whether the deploy script is available, and if so, the script is executed. Finally, everything will be cleaned up by the clean up build result phase. Later on in this video, we will show you how to add extra phases. An extra IKAN ALM feature is the possibility to add approvals to the execution of build or deploy levels. In that case, an approval mail is sent to the person responsible. Once he or she has approved the execution, the level request will be executed. As we have made changes to our project, the project first needs to be checked for consistency and be unlocked. As said before, IKAN ALM comes with a series of core phases which are attached by default to the levels and environments. You can, however, easily remove unnecessary phases and add other phases which will perform specific tasks during the build or deploy processes. In this example, we will add two solution phases to the deploy environment. The update database phase, which will reinitialize the database. In our example, this will remove the dummy customers created for test purposes. And the Tomcat deploy phase, which will deploy the build result to a Tomcat web server. To illustrate how easy this is, we will first import a phase. In the Global Administration section, we select Phases Import and we click the Select File button. We select the file and click Import. The Update Database phase is added to the overview. If we now click the Edit icon in front of it, we will see all the phase parameters and their default values. If required, you can modify those values. We will also use the Tomcat deploy phase, which has already been imported in IKAN ALM. The required phases are now available in the phase catalog. To use them in our deploy process, we need to insert them in the deploy environment. We will go back to the definition of our demo project, and on the deploy environment's overview, we click the Edit Phases icon. Inserting a phase is as simple as clicking the Insert Phase link, selecting the phase you want to insert, specifying its position in the sequence, and selecting the next phase on error. When done, we click Insert and the phase is inserted on the overview. We do the same with the Tomcat deploy phase and insert it after the update database phase. The value of the phase's parameters can be defined on different levels. You can find a detailed description of the usage of parameters in the IKAN ALM user guide, which you can download from our website. In our example, we need to adapt the name of the database on the deploy environment level. We click the View Parameters icon to display the different parameters of the update database phase, and we edit the RDBMS database name parameter to modify its value. Everything is now set to create a deploy level request. On our desktop, we click the appropriate action link, fill out a description, select the number of the build to be delivered, and click Create. On the level requests overview, we see the status of the level request. It is set to Waiting for Approval. This is because we added an approval to the deploy level. The person responsible for approving the level request will receive an email inviting him or her to approve or reject the request. The mail contains a direct link to the approval window in IKAN ALM. In the approval window, he or she clicks the Approve icon, adds a reason and approves. On the overview, the status of the level request is now set to Running. The level request is now started. When finished, you can check its details to see what happened by clicking the link on the overview. Just as for the build level request, this brings us to the level request detail page. On the Phase Logs tab page, we can inspect the update database phase, for example, and have a look at the actual values of the parameters. We notice that the correct database name has been used. Next, have a look at the Issues tab page. Our project is linked to an issue tracking system, meaning that all issues associated with the level request will be automatically linked to it. Clicking the Issue ID will automatically bring you to the correspondent issue in the issue tracking system, in this case JIRA. Another interesting tab page is the Approvals tab page, where you will find a record of who approved the level request. Let's now have a look at the final result. As you can see, the title of the application is changed, and the build number has been updated. The dummy customer has been removed, as the database has been updated by the Update Database phase. To finish, we'd like to show you one more interesting feature in IKAN ALM, namely the build history. On the level request details overview, you will find a link to that build history. When you click this link, you will see an overview of what happened for that specific build. In this case, the build has been delivered to test. The build has been initiated by a schedule and ended successfully. We see also that the deliver to test has failed once, and finally it was executed successfully. For each item in the level request history, a link is available which jumps to the detailed overview of the specific environment or level. On the detailed overview, the header also provides some extra links. These links lead to the level requests overview screen, from where you can continue to the detailed information of the level requests. This was our IKAN ALM solution in a nutshell. For more information on our company and products, we invite you to visit our website. If you would like to discuss any specific requirements, you can always contact our IKAN ALM specialists or participate in one of our webinars. Every Tuesday we organize 2 webinars. The first one at 10 AM and the other one in the evening at 7 PM, both Central European time. This live demo takes about half an hour, and afterwards we take the time to answer any of your questions. Thank you for watching.